Hey, how are you today? It's nice here, nice and warm now. Good old May. It's no longer snowing. So, yes, welcome to spring officially, when the snow has ceased. All right, let's do some math now here. So I'm going to go over those review questions that were at the end of the video there, and that's about it here. And then you have a homework to do, and just make sure you guys look back at this slide here that kind of summarizes everything a lot. Um, I'll probably, I'll post this PowerPoint here, but um, anyhow, you're going to be finding arc length for a lot of problems. Just remember there's 360 degrees in a circle. Arc length is a distance on the outside of the circle that is a fraction of the circumference. Okay? Um, a sector is a measurement inside, area inside the circle, which is a fraction of the circle's area. And a segment is really a part of the sector, okay? And so you really want to figure out the sector's area and then subtract the triangle here, okay? And that's it for the little review there. All right, so then there were all these ones here that I had you guys do. So here's the answer for the first one. I hope you guys actually tried these ones out a little bit. So if you're comparing these two circles and they give you their diameters, you can figure out how much greater area one is than the other by using the area equation, and then just do it for each circle and subtract it. All right, but you need to figure out the radius, because the area of a circle is pi times the radius squared. All right, so if the diameter is 60, you need to make it into 30 for the radius. All right, and then so you get about 1571 if you use the pi key, or 1570 if you don't. Just remember to follow the order of operations. You need to be squaring 30, then multiplying it by pi. If you just type everything in the calculator, it does the order of operations for you. So don't need to worry about that too much. All right, so there's the answer for number 2. All right, now let me actually go ahead and do that here on this over here. All right, so we're trying to figure out the area of a sector. Okay, so the area of a sector is a fraction of the circle's area. Okay, so the circle's area is pi times the radius squared. Okay, and then so how many degrees is the sector? Over 360 degrees in a circle, so it's a fraction of the area. So we have 135 degrees in this particular sector. All right, and we put that over 360. We're multiplying it by pi, and we're multiplying it by the radius squared, which is 8 here. Okay, just make sure that it's radius, not diameter, because we don't. If it was diameter, we'd have to half it. Okay, so there you go. 8 squared is 64. All right, and then what we're going to do is just grab our good old handy calculator here. It says leave your answer in terms of pi. All right, so what I'm going to do is just you can try to reduce some stuff here, but you could also just do, all right, this is what I'm going to do right now. I'm going to hit 135 ABC 360. Okay, this fraction here reduces to 3/8. Isn't that nice? Times 64 pi. All right, and then you could actually go ahead and cross out the 8. 8 divided by 8 is 1. 64 divided by 8 is 8. All right, so then we have 3 times 8, and there you go, 24 pi. Not so bad. All right, now let's go on to the tricky ones. Fun times. Okay, we got to figure out the area of the segment, which is part of the sector. So let's start by figuring out the sector's area. Okay, the sector is going to be 60, area of this sector, 60 over 360. And you reduce that, that's just 1/6. Divide 60 by 360. 60 into 360 is 6. Times pi times the radius squared. Okay, 13 squared is 169. So we have 169, okay, pi, and we're multiplying that by 1/6. Now, I don't know if 169 divides by 6. Actually, I know it doesn't. So we're just going to leave this for now. 169 over 6 pi is the area of the sector. All right. Now we need to figure out the area of that triangle. Now that's where things get a little bit dicey here. So you got this triangle. We know that on this triangle, the radii are both 13. Okay? Because radii are always the same. Each radius is the same, 13, 13. And we know this 60-degree angle here is just kind of chilling out there. So what we're going to do here is drop a height. Okay, 60 degree must be here. All right, we got to figure out the height of the triangle. All right, area of a triangle. We'll put A of a triangle. Okay, is equal to 1/2 the base times the height of the triangle. Okay, so I'm going to say the base is 13. Okay, now what is that height? Well, it's a little bit tricky. Alright, let's zoom in on this a little bit. Boom, there it is. Alright, so it's good to redraw that a little bit better so you can see it. Okay, so it's 13 across, so half of it is 6.5. We know that these two halves are equal because, well, you could prove it with, I don't know, hypotenuse leg theorem, something like that. So, yeah, probably hypotenuse leg. Because you know the shared side, you know that's 90 degrees. Or no, you could actually do angle side here. Yeah. Anyhow, so we're going to divide that in half. That's going to be 6.5. So the height is going to be equal to, all right, so let's think about that. So this is 30. 30 goes with 6.5. The height is across from the 60. So that is 6.5. multiplied by the square root of 3. Okay, you guys have to remember your 30, 60, 90 relationships. Okay, 30. 30 if 30 is s. 60 is s square root of 3. And the one across from the 90, the hypotenuse, is 2s. Okay, so that was from like the last section. So it's like kind of good that I taught you that because you can use it now here. Alright, so now we got the area of a triangle. And so let's just punch this into our handy dandy calculator and figure out what that is. Alright, it's about 73.2. And I also figured out this was about 88.5. Now remember, we're trying to figure out the segment. So the area of the segment, put area of the segment, is just the difference between the sector, which is the larger part, minus that triangle we just chopped off. Okay, so minus those two. And guess what? If you round it to the nearest whole number, it is 15. Okay, it's actually about 15.3 is what I got. All right, so we did that right. Yay. Okay, let's check out this one here. Doing the same thing. Find the area of the segment. This time it's a 90-degree triangle. So let's start off by getting the area of the sector. All right, which is going to be 90 over 360, because remember it's the part of the circle that is 1/4 if you reduce it, and then you do pi times the alt radius squared. Okay, pi r squared, that's the area of a circle. Okay, and I'm not sure what that's going to be. I'll punch it in my calculator in a second. Now let's talk about the area of the good old triangle. Okay, we know the height. Remember, the area of a triangle is 1/2 the base times the height. Well, the radii are both the same, so they're both 22 here. So the base is 22, and the height, it's perpendicular to the base. So guess what? That is also 22. Isn't that cool beans? Or cool something? I don't know. Ice cold math there for you. Ice cold math. Alright, let's punch it into our calculator. Alright, we got 242 inches squared for the triangle, 380 for the sector, and if you subtract those, you get 138 inches squared, which is the shaded segment. Okay, so just remember, sector minus the triangle equals the segment. All right, that's it. Have a great day, guys. Take care. God bless. Bye-bye.